Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at multiplication, and we're going to think about multiplication using scaling. And scaling is about things getting bigger and things getting smaller. So let's draw something to help us think about this. Let's start with somebody. We'll call this person Sam. Let me draw a picture of Sam here. And Sam doesn't look like a very big person right now. But Sam will matter a lot in our story here. Let's give Sam a happy face. Okay, what we know about Sam is that Sam is, 1, 2, 3, 4 feet tall. Okay, and we know that Sam is 1 times his own height, so he's 1 Sam, 1 times Sam. Okay, great. But what if another person comes along? What if this person is named, Tina? And Tina is taller than Sam. Let's make Tina about this big. And Tina is obviously taller than Sam. Let's think about that in terms of scaling, about things getting bigger and things getting smaller. So here's our picture of Tina. And Tina also has a happy face. But what do we know about Tina? Well, we know that Tina is taller than Sam, but by how much? Well, we measured over here before. This is 4 feet altogether, and we can see that here, right? 1, 2, 3, 4 feet. So we're 4 feet tall at this point, but look how much taller she is still. She's still another 1, 2, 3, 4 more feet. She's 2 times 4 feet instead of just 1 times 4 feet. So we can say that Tina is 2 times as tall as Sam. All right? But how tall is that? Well, we know that Sam is just 4 feet tall. But Tina is 4 feet and 4 feet more, or 2 times as tall as Sam. Well, 4 feet and 4 feet more makes 4 and 4 is 8. So she is 8 feet tall. She's quite tall. All right, what if another person comes along? What if we found George along the way? So this is George. And George is also quite tall. Let's draw a picture of George. All right. And George is a very, very tall person. Must have to buy extra, extra large clothes, huh? All right, here's George. And George, like Tina and like Sam, is having a good day. Now, what do we know about George? We know George is taller than Tina, and we know that George is taller than Sam, but by how much? Well, if we start counting, we can see that George is 1, 2, 3, 4 feet tall here, so that's 1 times as tall as Sam. 1, 2, 3, 4 again, that's twice as tall as Sam, just like Tina was. And 1, 2, 3, 4 more. We can see that George is 3 times as tall as Sam. And how tall is that? Well, we can see 4 and 4 and 4 more add up to 12 altogether. So we know that George is 12 feet tall. So we can see that if Sam is just 4 feet tall and Tina is twice as tall at 8 feet, we know that George is 3 times as tall at 12 feet, 3 times as tall as Sam. What if Maria comes along? How tall do you think she's going to be? What's the pattern? So let's draw a picture of Maria. Here's Maria. And she probably has to get really big clothes too. Very, very, very tall, isn't she? And she's having a good day too. Okay, but how tall is she? Well, we know that she's 4 feet tall here, because we can compare to these as over here, right? This is 4 foot, 4 foot, 4 foot, 4 foot. So she's 4 feet tall here. This next measure is also 4 feet, just like here, right? This next measure is also 4 feet. And this last measure is also 4 feet. All right. What does that tell us about Maria? Well, Maria is, let's see, if Sam is 1 times 4 feet, she's 1, 2, 3, 4 times as tall. So we can say that she's 4 times what Sam is. And if Sam is just 4 feet, she's 4 and 4 and 4 and 4 more. Well, how much is that? 4 and 4 is 8, 8 and 4 is 12, 12 and 4 more. That gives us 16 feet. She's quite giant. Okay, what's going to happen next? Well, I think that Fred comes along. And Fred, well, you know what's going to happen here. Fred is quite tall. So here's Fred. And Fred also probably has to buy clothes at the same store that Maria buys her clothes. And they probably have to be the extra, extra, extra long sizes, right? And so Fred is quite tall, has quite long legs. I bet you he has big shoes too, huh? And Fred, like everybody else, is having a very good day. But what do we know about Fred? We know that Fred is at least 4 feet tall, and then at least another 4 feet tall, and then again another 4 feet tall, and again another 4 feet tall, and one more measure of 4 feet tall. That's taller than anybody's ever been. But if we look at Sam, Sam is 1 measure of 4 feet. How many measures of 4 feet is Fred? Well, Fred is 1 measure, 2 measures, 3 measures, 4 measures, 5 measures of Sam, or 5 times as tall as Sam. Well, how much is that? Let's count them. 4 and 4 is 8, 8 and 4 is 12, 12 and 4 is 16, 16 and 4 more gives us 20. So Sam is 20 feet tall. Quite giant. All right, now we can see how they're growing. 4 to 8 to 12 to 16 to 24. What do you predict for the next one? Well, you know it. Somebody else has to come along, and this person, her name is Anna. And Anna, let's see, yes, she's very tall. Let's draw a picture of her. All right, Anna. And where do you buy your clothes, Anna? At the extra, extra, extra tall shop, right? So she's getting her clothes at the very tall, tall shop that all these people have to go to. And imagine how long her pants have to be. She must have very, very long pants. And think about how far she has to reach to tie her shoes. So here's Anna, and you know it. She's having a very nice day. We also know that Anna is 4 feet tall, and another 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 4 feet tall. How tall is that? Well, if we know that Sam is just one measure of 4 feet, we know that Anna is 1, 2, 3, 4, 5, 6 measures of Sam, or 6 times as tall as Sam. How tall is that? Well, we have 4, and 4 is 8, 8 and 4 is 12, 12 and 4 is 16, 16 and 4 is 20, 20 and 4, that's 24 feet tall. So Anna is 24 feet tall. That is by far the grandest. So Sam was 4 feet tall, Tina 8 feet, George 12 feet, Maria 16 feet, Fred 20 feet, and Anna 24 feet tall. Now let's think about this in terms of scaling. What's happening here is that Sam is made taller and taller with each different person, right? And this is growing, getting larger and larger through scaling. So scaling is about a measure becoming greater and greater in proportion to the first measure. If this is 1 times Sam, this is double Sam, this is triple Sam, quadruple Sam, 5 times Sam, and then 6 times Sam. And that's about growing in terms of scaling. But I do want to show you one other thing, and I think this will help to make it understandable. Let's start again with Sam, and watch how Sam grows. Sam grows to be twice as tall in Tina, 3 times as tall in George, 4 times as tall in Maria, 5 times as tall in Fred, and 6 times as tall in Anna. So we can see things growing and growing. Now, that's one way that scaling works. The other way that scaling works is that things can be shrinking too. So let's think about that for a minute. If I look at Anna, who's 24 feet tall, she's 6 measures of Sam, can we find the person that's just half as tall as Anna? Who's half as tall as Anna? Well, we know that 6 times Sam, half of that would have to be somebody who's not 6 times Sam, but half of 6. And who is that? Well, if we go down, if we shrink, 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 we see that George is just half of 6. George is only 3 times as tall as Sam. And if we look at George and we compare George to Anna, we can see that George is just half as tall as Anna. So we can shrink people too. So a person that's half as tall as Anna is only 3 times as tall as Sam. And we can think about it this way too. What if we were looking for somebody who was half as tall as Maria? And Maria is 4 measures of Sam, or 16 feet. If we're shrinking the other way, who would that be? Well, if we know that Maria is 4 measures of Sam, we need somebody who's half as many measures. Well, half of 4 is 2. So 2 measures of Sam, shrinking, shrinking, takes us to Tina. And if we look at Tina, Tina really is only half as tall as Maria. So multiplication with scaling means things getting bigger, stretching, stretching, taller, taller, bigger, bigger, or it could be the other direction too. So scaling is a very interesting and important idea when we think about multiplication. I do hope this has been helpful to you.